Today's video will be about base E and natural logarithms. E is an irrational number. With an approximate value of 2.71828 ... because it goes on forever. This is very similar to pi, so you should think of E as an actual number with a value, just like pi is equal to approximately 3.14, and not think of it as a variable. E is often occurs as the base of exponential and logarithmic functions that describe real-world scenarios. So there's a long, in-depth explanation of what E is and why we use it, but it goes way beyond Algebra 2. So I'm just going to let that be a fact that we accept right now, and we're not going to ask why. If you want to ask why, you can research that on your own time. Okay. Exponential functions with base E are called natural base exponential functions. For example, f of x equals e to the x power would be a natural base function, or natural base exponential function. Logarithmic functions with base e are called natural logarithms. For example, this would look like f of x equals log base e of x. However, we're never going to write this. We don't want to use log base e. Instead, it's abbreviated as f of x equals ln of x. And the ln means natural log. So just like log x means log base 10 of x, ln x means log base e of x. Okay, so this is just an abbreviated way to write a very commonly used logarithm. When we convert between forms, we do this the same way as when we converted regular logarithms. Okay, so e to the x power equals a is going to be the same as natural log of a equals x, because this is log base e of a equals x. Okay, so we don't want to use this notation, but to help you understand what this means and where it comes from, I want you to see that it's really the same conversion that we've already been doing. So just to help you visualize it better, when we convert from exponential to logarithmic, our base stays the same, so log base e. Then your exponent and your answer you switch the order of those two. So log base e of 24 equals x, but log base e is really just natural log. So you can skip from there to here if you'd like, or if this step helps you, that's fine too. Just don't ever leave your answer like that. All right, then to convert the other way around, you can recall that this means log base e of x equals 58, which would mean e to the 58th power equals x. And this would be our simplified version, well, our appropriately converted version. Now we're going to look at condensing and expanding. These are the exact same properties as a regular logarithm. We're just using ln instead of log. So I'm going to do number 9 with you. Your coefficients come up and become exponents. So this is going to be natural log of 64 to the 1/3 power plus natural log of x squared. Then addition condenses to multiplication. So it's going to be natural log of 4x squared, because 64 to the 1/3 power is the cube root of 64, which is 4. So this is our final answer. Then I'll do number 12 with you as well. So on number 12, we have the natural log of the cube root of m squared n. So this is the same as natural log m squared n to the 1/3 power, because we can write a cube root as an exponent of 1/3. Then if we take these to the 1/3 power, we have to multiply the exponents. So the natural log of m to the 2/3, because 2 times 1/3 is 2/3, and n to the 1/3. Then we're going to separate that into addition, because multiplication expands into addition. Natural log of m to the 2/3 plus natural log of n to the 1/3. And finally, we bring our exponents down as coefficients. So our final answer is 2/3 natural log m plus 1/3 natural log n. Now we're going to talk about solving equations. Solving equations with natural logarithms are the same method as solving regular logarithm equations. Okay, so in this equation, we have a logarithm equals a logarithm. So we just set the inside of each one equal to each other. And then solve for x. So we're going to get 6x equals 42. Then divide by 42, or divide by 6, and x equals 7. Then don't forget to check your answers. When you check your answers in natural log of a, you are making sure that a is greater than 0. So we have to plug 7 into this and make sure they are both greater than 0. So 4 times 7 minus 27, that gives us a positive number. 15 minus 2 times 7 gives us a positive number. So x equals 7 is in fact the solution to this problem. All right, for number 15, you have to condense before you can evaluate. So we are going to have log equals log, but right now we have too many logs. So subtraction condenses to division. So we're going to get natural log of 18 because 72 divided by 4 is 18. On the right side, addition condenses to multiplication. So we will get natural log of 6a minus 12 because that's what 6 times a minus 2 gives us. Now we have a logarithm equals a logarithm, and we can set the inside parts equal to each other. 6a minus 12. Then we want to just solve for a, so we get 30 equals 6a, and a equals 5. Then the only logarithm that has a in it is a minus 2, so to check our answer, we say 5 minus 2, that's a positive number, so a equals 5 is a solution to this problem. Number 17, natural log of 8x equals 2. This problem is log equals a number. So we have to convert to exponential form to solve this equation. Now recall that ln is the same as log base e of 8x equals 2. So when we convert this, we should say e squared equals 8x. My goal would be for you to get comfortable enough with a natural log that you don't have to write down this step, that you can just skip from there to here. But for now, I understand you might need that to lean on to remind yourself how to do it. So remember that e squared is a number that has a numerical value. It's not just a letter. So when we divide both sides by 8 to solve for x, we're going to get x equals e squared divided by 8. Then we can type this in our calculator. I'm going to bring up my calculator on the screen to show you how to type this in. So what we need to type in is e squared minus 8. If you look at your calculator, the log button is beside the 7. We've been using that. Below it is the natural log button. If you hit second and the natural log, you're going to see that that shows you e to the x power. So we are going to type second natural log. We want e squared, and then go out of the exponent and divide it by 8. And hit enter. So your answer for this problem should be 0.9236. So x equals 0.9236. Now, anytime you start with a logarithm, you have to check your answers. So we want 8 times our answer to be positive, and it is. So this is the solution for this problem. All right, number 22. This one is exponential, so we are going to solve using logarithms. So we have to get the exponential part of this equation by itself, and the exponential part is only the exponent and the one thing that it's applied to. So we're going to subtract 3 to get 2e to the c minus 9 equals 84. Then we'll divide by 2 to get e to the c minus 9 equals 42. Now we have e to the something power equals a number. So we can say natural log of 42 equals c minus 9. Now, if you need to see this is what I want you to be doing in your head, but the step that I skipped here that I could have shown you is log base e of 42 equals c minus 9. But that's the same thing as what we've already written, okay? So hopefully this is getting ingrained in your brain and you're not having to do that step. That's our goal here. All right, so then we're going to have natural log of 42 plus 9 equals c. And keep in mind that plus 9 is not part of the logarithm. If parentheses help you, feel free to use that, but you cannot combine that 42 and the 9. So in your calculator, you're going to type in natural log of 42 plus 9. So we'll go ahead and show you what that looks like. Natural log 42 end parentheses plus 9. So our answer to this problem should be 12.7377. C equals 12.7377. And because this was exponential, we do not have to check for extraneous solutions. This is the solution to the problem. All right, thank you for watching and have a great day.